This is the small.
I think we're ready, gentlemen.
We're on the air.
I think we're on the air. My God, look at these five elderly gentlemen.
And us too.
We all wearing glasses? Tom Whittemore's not. I'll introduce everybody in a minute. Hello there. Okay, man. Following a great online talk with UCSB's Physics Department Chair, Dr. Claudio Campagnari, for our big club on Friday night. This will be our 85th episode, ladies and gentlemen, of the SBAU Astro Hour, live from the board members' computer dens and man caves, and all for the members and potential future members. We're getting them. We're getting ready to open up again for the Santa Barbara Astronomical Unit, our longtime telescope and astrophysics club. I'm Ron Heron, former radio star who should have been an astronomer because I love this stuff. Here's what we're going to talk about this week, Monday mornings, 11 a.m., live on YouTube, and you can comment on things or ask questions. Our new morning star turns out to be our smallest planet, Mercury, these days. The moon is flipped out on us. It's flipped over to waning, but is it waning outside? No, it's still full. And our seventh planet is going to be occulted by it, but I don't think we're going to be able to see that. It's mostly north. We can talk about it. One of our guests here, the outreach gentleman I'll introduce you to, is an expert on the occultation, normally little dinky things like asteroids, hanging out with Mars as well. And we're going to tour Mari on the surface of the moon. Variable star of the month is Mira. And it's the first time, apparently, we've seen a supernova from beginning to end, and it is violent in a distant galaxy. Let's meet the gang. Jerry Wilson, president for 5 years. How are you, Jerry?
Good morning. I'm good.
And he doesn't like to be called doctor, but he could be because he's got the degree. Chuck McPartland is our outreach coordinator. And like the rest of us, a definite supporter of the Ukraine. Chuck's married to Pat, our merchandise manager. Jerry Wilson's also married to a Pat Forgy. And Tom Whittemore joined us. His wife is
Morning.
Hello, Tom, former Western College science instructor who they all keep begging to come back. And he keeps saying, get away from me, quit calling. Editor of the Santa Barbara Astronomical Unit newsletter. And Bruce Murdoch is on our screen. He checked in early. His wife is Bonnie, a longtime active member, and happens to also hold the title of the Santa Barbara Theater Organ Society president. And my name's Ron Heron, and I'm proud to be vice president. Mr. President, I guess just to recap Saturday's board meeting, we're going to try to get back into the Farron Hall live in-person meeting on December's first Friday, aren't we?
Yes, we're committed to do that.
Okay, that'll be December, what, 2nd?
I think so, yeah.
Okay, we'll see. We had one, false alarm already. We were going to reopen in August. And
It'll also be our general election for officers. So if anyone is dying to be an officer, say your name.
And then you and Chuck McPartland over here are going to be talking at least, and then we could use a third talker for the hour, giving you each 20 minutes. Do each of you know what you're going to talk about?
Yes.
Can't tell us yet? Give us a
Astronomy.
time. What?
Astronomy.
Okay. Well, then let's have a little levity, gentlemen. Start the hour off for the benefit of the folks who haven't seen the forward and silly science cartoons that President Jerry sends us all the time. I've got my comments here. If Jerry, who is running webmaster duty, I don't know where Tom Totten is. Okay, here we go. Looking at the moon. Is this the impact one? Let's see.
This is fantasy.
Ah, yeah, there it is. They're in a space, turning space. What is that called? A space station.
It says, "Are you serious?"
Oh, did I have that written down? I guess I did. Anyway, the gentleman says NASA will be sending a crew to land on the moon in the near future if they ever get Artemis off the ground. It's a very demanding mission, requiring thousands of hours of calculations and planning, gentlemen. They should go when there's a full moon, bigger target. Yeah, all right, I'll pass that along. Yeah, right. There's another one in that series too. No, that's not the one. That's the black holes one, green alien. News reporter broadcasting back home, phoning home behind a tree near a mobile food truck that sells fresh donuts. Hello, humans have mastered black holes. They do eat them. There it is. I like the black holes. Oh, here we go. This got to be Winnie the Pooh.
Yep.
I don't really get it because he's in a casual sweater and it says proton 2, or no, just a proton. And then the second one, it says H1.
Ionized hydrogen.
Yeah.
Which is also a proton. It just sounds fancy.
Well, it has an electron around it if it's an atom.
No, that's what the plus is. The electron is missing.
Right.
It's just the proton, just the nucleus. So they're both proton. This one just sounds more efficient.
I got
They
you.
had to be there.
Yeah. Well, whoever drew this cartoon, I hope they got permission from. Oh, here we are, out in space again. So sent a manned mission to the moon, did you? And an unmanned probe to crash into an asteroid going to change its path? Well, the manned mission is called Project Impact. And the other astronaut says, I thought that was the probe mission. Uh-oh. Rushing into the wrong thing. Here we go, gentlemen. They're not all knee slappers. This professor makes a horrifying discovery. Sitting at the computer desk, messages sent across the universe by advanced alien civilizations in unknown solar systems have all been going into her junk mail folder. What mail? That's where they ended up. Doggone. Okay, here's Aunt Beth talking to the kid. And thanks to this incredible sensitivity, they were later able to use her to detect gravitational waves. Who are they talking about? None other than the Princess and the Pea. Silly story, a fairy tale about the princess. How many stacked mattresses?
Oh, I don't know, 9 or 10 or something.
Yeah.
I don't know the story other than that. I guess.
Oh, that's it. That's it.
That's
The
pretty
joke
much
is as funny as you're afraid it is.
So LIGO detector of gravitational waves. Here we go.
The LIGO detects motion of the distortion of the Ethereum, if you will, what do you want to call it?
Gravitational waves.
Right, but it's a fraction, like a thousandth of or even less of the diameter of a proton. I mean, it's just tiny, tiny, tiny.
Yeah, it's unimaginable.
I think we've talked about it, and it'd make a good subject again. So these gentlemen no longer look through the telescope; they look at the view on the screen of Webb telescope's pictures. I'm seeing stuff you wouldn't believe that it's supposedly watching out there in space on YouTube. So, gentlemen, are there any more sillies coming up? Oh, I like this one. We've all heard 2 wrongs don't make a right. Well, here's a couple scientists standing at the blackboard. One of them explaining the formula. Yes, I know that, Sydney. Everybody knows that. But look, 4 wrongs squared minus 2 wrongs to the 4th power divided by this formula do make a right. So, okay. Oh, is this? No, we're done with the silly stuff. And we're all relaxing on a Monday morning with overcast and no watching tonight if it stays like this, but it usually clears up, doesn't it, by nighttime? How was the star party Saturday night, gentlemen? Those who were there.
Worked out fine.
How many people you think you had?
204.
Oh, wow. It was overcast at my place.
Yeah, it was. There were clouds here and there, but they were polite. And so
Yeah.
we had the moon and we had Jupiter and we had Saturn.
How many scopes did you have set up?
7.
So who, you want to give any credit to anybody that showed up and helped us?
Oh, it'll be in the newsletter.
Oh, okay.
It was the usual crowd.
Okay.
It was the first time I'd seen Martin in a while, not due to his absence, but due to mine.
Yeah.
Yeah. Well, the moon is full still, and it Sunday, yesterday it filled up, but Mercury is the new morning star, and it's close to the sun. Rises 90 minutes before the sun is 5 degrees high in western sky Virgo.
This is the sky. Can you see this?
Yeah.
We're sharing. Okay, this is the sky at 6:30 in the morning on the 11th, tomorrow morning. And this shows Mercury down here, just up. I don't think the sky is this dark at 6:30 in the morning.
No.
But, it makes a good map. So it shows where Mercury is directly under Leo. It's now the morning star. It's quite bright, but you have to have a really good, I call this a Kansas horizon, to be able to see it in the east this early in the morning because it's just up. Have you seen it, Tom?
No, well, no, because of the fog, Jerry. But
Okay.
we'd easily see this. Okay, we have a really good horizon in the southeast.
Yeah, you're up on the hillside.
Yeah.
Did I miss you saying what happened to Venus?
I didn't say what happened to Venus, no.
Why isn't it the morning star or the evening star? Or
It-
is it evening now, I guess, right?
No,
No.
not yet.
Not yet, but a month and a half ago, I really struggled to see it in the morning sky. Even we had clear morning skies.
I think it's still in conjunction or it's just passed.
We're getting real close, one or the other.
Yeah.
Yeah.
So it's on the other side of the sun.
Yeah.
And that's why we don't. Okay.
And it doesn't move very fast at that part of the orbit compared from our point of view.
Boy, look at all those
Mhm.
jaw-dropping
Now this is
Messier objects there.
Yeah.
This is a preview of the sky as it will be in April overhead in the evening. All these galaxies in Coma Berenices. So
Downtown Virgo.
yeah, downtown Virgo.
Can't see them now.
No. Well,
Well, it's too bright at that time.
Yeah. Yeah, this map is optimistic on how dark it is at this time of the morning.
So all those yellow numbers are
It'll
galaxies.
Most of those are galaxies, if not all.
Do they have M
Yeah,
numbers?
it's a rich part of the sky.
Yeah.
Okay. But none of them are clusters.
some of
No,
them are.
Okay.
Yeah. The ones
Well-
up Leo, Ron, are, there's one of the Leo triplets there, M105, 95, 96. And then 65 and 66 are joined with one that's not on there. It's an NGC galaxy.
And old man Messier, when he gave him those numbers, knew the difference. He knew he was
No.
looking. He didn't.
He didn't know what he
No.
was looking at.
Right. They were just fuzzy things that didn't move.
Wow.
Yeah, he was looking for comets.
Yeah.
These are fuzzy things that didn't move.
Yeah.
at least not very fast.
Yeah.
Okay, well, it's the only bright star or the bright planet early in the morning now. A couple months ago, they were all lined up in the morning, but now they're moving toward midnight and they're transitioning into the evening sky. You can see Jupiter late in the evening.
It's very bright too.
Yeah,
It's about thing up there.
And it's not all that late these days. We were looking
No.
at it last night for the
Yeah.
school out at El Capitan Canyon.
yeah.
Right. Yeah, and Friday evening, we had a dinner guest here, and I wrote to Chuck about it. And we got Jupiter real early with the moon. It was really pretty. It was almost the full moon, the hunter's moon, they call it in October.
Yeah, this is the hunter's moon.
South
Okay, the next topic is a possible occultation of Uranus by the moon. This
I
is
sent
a-
you some pictures that I had taken of the moon in an eclipse in Uranus from Westmont.
when,
Basically, the moon's going to go across it, right?
yes,
Oh, yeah. Moon's going across it.
the moon's in front.
Yeah.
It'd be tough for Uranus to go in front of the moon.
But we're not going to see it disappear. We're only going to see the reappearance.
I
And
see.
this is a map where you can see it, and it's mostly very far north.
Mhm.
These two loops show an egress and what do they call it going behind it?
Ingress.
Ingress. Mhm.
Not a word I use much. But egress and ingress for these loops. For us, this white line, that's egress only. So you won't see it go behind the moon, you'll see it come out of the moon. And we're down here on the coast of California, very close to the minimum line that we'll see anything at all. And
For us, it's tomorrow night at around 10:37.
Okay.
Provided there aren't a high cloud layer.
Yeah.
this is supposed to be universal time, 6 hours That depends on where you are. But let's see if I have that written down here.
You have the time for Los Angeles, and that's essentially good enough for us.
Yeah, that's right. And that's 5:37. So that's 12:37 a.m. here.
Well, no, it's 10:37 here.
Okay.
We're earlier.
I had thought that universal time is the same as Greenwich Mean Time.
Well, we're in summertime now, so you're subtracting 7.
Okay, I had subtracted 5. So we'll have to work that out. You might be right. You're usually right when we disagree. So
Well, I'm just used to doing this for occultations because they're in universal coordinated time.
Okay. So anyway, let's see if I can get this to blow up. My planetarium software shows this just egressing at 12:30. So
yeah, if you zoomed in closer, it would be quite a ways away from the moon by then.
Yes. Yeah, this is not very high precision in its graphic. So.
But the reason we won't see Uranus go behind it is it hasn't risen yet. It's below the horizon.
Yes.
They're both out of sight from the other side of the world, right?
Yeah.
This also make it run real easy to find Uranus in a little telescope.
Yeah.
That's true.
Well, you have to kind of guess where it's going to pop out from the dark side of the moon.
Yeah. So you want a wide field of view, so you're looking at a significant section of the terminator or the limb.
It seems to me it was around like the 4 or 4:30 position.
Either of you want to repeat your statement there? You covered each other.
I said, Jerry, did you see the pictures that I just sent you of Uranus and the moon?
No. Did you just send it to me?
Yeah, 10 minutes ago, 5 minutes ago.
Okay. It's hard for me to get at my email the way I've got this configured right now. Can you share the picture?
That doesn't work well on it.
Okay.
I just emailed you it was on the 14th of whatever it was, the 8th of October 2014 at Westmont. There was well, on that day there was a lunar eclipse, which I photographed from Westmont. And at the eclipse maximum, the blood moon, there was a little blue dot in my picture, which I didn't see until I got home to process it. Well, that's planet Uranus. And because the moon was, very dim because of the just the blood moon, it really stood out.
Oh, so your picture is just a blue dot. I thought you were showing surface features with your. No, just joking.
Not with an 8-inch telescope.
No. Okay, so that's something to look at.
Yeah.
We now have.
And as far as position on the moon, when you're looking for it coming out, it's going to be at, I guess it's hard to say 12 o'clock face on the moon unless you're projecting longitude on it, but it's going to be looking up at the moon as far as just what you perceive as up and down. It's going to be at about the 3 o'clock position, popping out near Valles Reita. So Rheita. So just near the limb where that valley and that crater Rheita are is where it'll pop out. If you want to, if you want to try to look at higher magnification.
So this has it, assuming up is the same direction. This has it at about 3 o'clock.
Yeah.
And it's when the sky 6 predicts it's going to pop out. Okay. Going to the progress on the comet, the new comet, which is not going to get very bright.
E3. Actually, the full name is C/2022 E3, and in parentheses ZTF. I don't know what that means.
Yeah, but it's only passing through, so I decided not to memorize its name.
Oh.
ZTF stands for Zwicky Transient Factory.
Right.
And that's a telescope down by Palomar that they use to look for moving objects.
And they found it, you think?
Yes, or they wouldn't have named it that.
Is Pan-STARRS gone?
Nope. Well, Pan-STARRS is a system that they use to look for to things like comets, and there are several Pan-STARRS comets.
Oh, well, we've been talking about one, and then they called it Pan-STARRS.
Well,
That's
it's
Pan-STARRS
Pan-STARRS, but it's
down.
also got the C/2016 B3 and numbers like that in it.
Okay.
There will probably be several ZTF comets too, but this is this particular one.
This
This is
new one will be brighter in next year, 2023, magnitude 6. It's now
yeah,
magnitude.
it's not going to be a spectacular comet.
Okay. But it's floating nearby Corona Borealis.
Yeah, right here, the constellation Corona Borealis. And it's on the border, it's heading into Serpens Kaput.
Okay, right.
Right now, this is a position for 1013, which is Thursday. And over the next week, it's going to move down here past Delta Corona Borealis and be down in this position by, what is that? About the middle of the next week.
The 21st, yeah.
21st, about Friday of the next week, the day before our Kachuma camp out and catered meal.
Well, some of us will be camping that night.
Yes, that's true. So it should be a good opportunity, provided it's not cloudy, because the moon will be not a problem by then. It'll be last quarter or even fainter.
The big problem is Corona Borealis will be real low in the west.
Yeah.
And there's a magnitude 5 star in that constellation called Delta Coronae Borealis.
Right there, Delta. See the little Greek symbol for Delta? And you find that in the constellation. See, this is Gamma and Alpha. So these are the bright stars that form the constellation of Corona Borealis.
Just 3 in a row?
Well, there's more, but they're off the screen. This is this is one of those astronomy maps. They're pretty bad.
Yeah.
Reminds me
And
of
this is a variable star, R Corona Borealis.
It's like Orion's belt.
Well, it's not as big or dramatic or as bright as Orion.
Ron, you can see the line continues up and to the right and off the screen. There's an arc of stars here, and so it looks like a crown, and they call it the Northern Crown, Corona Borealis.
Okay.
You know, the problem with all these astronomical diagrams where they have the star size diameter is proportional to its brightness. You know, it like the Corona Borealis is easy to see. It's kind of an upside down C. But you take a look at this diagram and there's too much other clutter around it to see that shape.
This is zoomed in too close for you to see the asterism of the actual crown.
Oh,
And
okay.
that's the problem that I think I have with it. But they want to show how close to Delta it's coming.
But isn't the word Borealis also contained in what we call the Northern Lights?
Well, Borealis means northern.
Northern means northern.
What it's so Aurora Borealis is the
Yeah.
Northern Lights.
And there's also the Aurora Australis.
Okay,
That's on the other
Australis
side.
would be south, of course.
Right.
There you go. I keep learning stuff from you guys. That's why I hang around like a puppy dog.
There's also a Corona Australis too.
Oh, is it really?
Yeah.
I just said that.
It's on, where is it?
It's the wedge of lemon under the teapot.
Good job, Chuck.
So I learned something from constellations the other day that I didn't know. Someone was referring to a constellation called Mensa. And I thought that was an exclusive club. And I thought that's not a constellation, they're making things up. So I looked it up on a star map, and it is a small constellation right near the South Pole.
Right. It's a table, like Chuck said.
Okay. Oh, so it's like a mesa.
Table. It's like
Yeah, I think it's in honor of the South African. There's like a bluff,
A plateau.
mesa like that above
Johannesburg.
Cape Town, I think it is in
Cape Town,
South
okay.
Africa, where John Herschel set up his telescope to study the southern sky.
Mhm.
Well, doesn't our occulting planet Uranus have a moon called colonoscopy?
Yeah.
All right, enough of the jokes.
You really have to squint to see it, though.
That's right. Okay, guys. It's the same picture or a different view?
No, this is not a view of what was the comet we're looking at? This is the variable star of the month, Myra, or
Yeah.
Mira. I don't know how to pronounce it. But this does back off a bit. It's still a little cluttered, but between Aries and Pisces, and it's in Cetus, which is this is the circlet of Cetus, which we looked at before, and this is the rest of it. So this is the variable star. What do they say about that?
Yeah, which peaked out in mid-July, Jerry. At about 3.5. It doesn't get real bright. So it's about magnitude 3.5, right around my birthday in the middle of July.
Yeah.
I'm not sure if you can see it now with your eyes. You could surely see it with a scope. And it's a big red carbon star.
Mm-hmm.
Yeah.
Yeah, they don't mention how, I thought I caught how bright it was, but it doesn't.
When it gets brightest, Jerry, I think it's 3.5 roughly. And this, when I was teaching Astro at Westmont, I gave the students a really interesting problem about, with the naked eye, how much of the year could they actually see this star is pretty interesting. I think you can only see it with your eyes for about maybe 30%. I don't remember the exact number, 30% of its cycle. Okay. Which I think is upwards of a year, some. Okay.
It says in the write-up, it says 332 days for the cycle.
Okay.
And second magnitude to 10th magnitude.
Yeah.
Oh, did it say second, huh, Chuck?
Yeah. I don't know how accurate it is, but.
Okay. I know it was brightest in July. Okay. And I can't swear about the magnitude, Chuck.
Yeah,
the
neither
name,
can I.
it was called Myra by Johannes Hevelius, which means wonderful, in the 1600s. It doesn't say that he discovered it, though.
Well, I think the Arabs saw it long time ago.
I'm sure they did, and probably noticed its variability, too.
Right. It would disappear. It was, you couldn't see it anymore. And then it would appear,
And that was sort of a no-no in non-Arabic countries because the stars were supposed to be heavenly and unchanging.
Yeah.
Yeah. Well, people turn a blind eye to it.
Yeah.
So this is up and easy to find about 10 o'clock local time in the evening.
Okay.
And this again is Cetus the Whale. There's its front legs and its tail.
This is a really non-standard representation of it, actually.
Right. May I make a comment about Beta over there on the right?
Go ahead.
I know it as Kaitos, which means the tail of the beast. Yeah.
And I think it's also called something like Difta.
I think that's right too, Chuck. Yeah.
Yeah. So there's Beta, Eta, Theta, Tau, Alpha, and Gamma. Alpha has a name of Menkar. So none of the rest of them are listed. Oh, there's Iota way up there.
It's a pretty dim constellation, huh?
Yeah.
Yes.
And in the traditional representation, Menkar over there is the head. And then, like you said, Beta, Deneb Kaitos is tail of the whale. But if you flip it around and draw the lines a little differently, the stuff to the right looks like the head of a whale, like a whale with a large head, a baleen whale. And then the Menkar little loop over there looks like the tail.
Yeah. And Ron?
Yes.
Eta is the past tense of Eta.
Eta is the past.
Right, that's a joke.
Yeah, that's a bad joke.
I got it. What I'd like to know, though, is the American Association of Variable Star Observers. I'm not sure. Who are those people? Just astronomers?
Well, I used to be one, Ron.
Really?
When I was a little kid, yeah, I used to get these charts from Cambridge, Massachusetts. And out there in the cold with my little 6-inch f8 telescope, I used to try to figure out how bright the target star was as compared to the field stars around it. So you'd get a chart with very good detail. And they'd have these known stars sitting around the target stars, and they would tell you how bright they were. And then you'd have to estimate how bright the variable star was that they were interested in.
Now, the star you're looking at, you have to estimate whether it's brighter than or less or dimmer than a given
Yeah.
star in the field, and then then you go around it and you collate your guesses or your opinions, and then
Yeah.
you come up with a brightness and send it in.
Right. And I was doing this before the camera was invented.
Ah,
It was a long time ago, but people, of course, do that.
As long as you took the cover off your covered wagon, you probably could have done it from the.
Yeah.
Well, they have enough variables up there to last forever without ever repeating. It's 12 a year they got to
Yeah.
come up with, right?
Yeah, the thing about Myra, Ron, remember, it's a long period variable carbon star. So it takes this long time to pulsate, basically. Okay. So AVSO was very interested in a whole bunch of people taking a look at this during the course of, say, a year, when you could see it.
So just to clarify, more than half of the stars, like binaries, are more than half, but more than half pulsate. The rest are like our sun, right? That never get larger or smaller.
Yeah, these stars, I think in general, are pulsating stars. I don't know if there are any eclipsing ones in the AVSO, but they probably are.
Yeah, there are. Yeah.
Okay.
But
And they do cataclysmics too. So it's not all pulsations, Ron.
Mhm.
would they classify a Cepheid variable? As
That's
a,
a pulse. Yes, sure. Of course.
That pulsates, that breathes. Mhm.
okay.
That's a regular variable. Anyway,
Yeah.
this is a good neighborhood for looking. Here's Jupiter up here.
Yeah, neat.
And then here's Uranus over here.
Okay.
And then Aries with its distinctive animal-looking bar between alpha and beta.
And that's when looking at the Uranus popping out from the moon, you just move over to the right a little bit and try to look at Myra.
Yeah.
I'm just going to point out, Jerry pointed out Aries up there. You can see the alpha and the beta. Okay. The other star there, Gamma Ariatus, is a beautiful double star. It's a gold.
Mesarthim?
I'm sure Chuck shows it at star parties.
Is it
Oh, yes.
Mesarthim, I think, right?
Is this gamma here?
Yeah.
Mhm.
Okay. It's
That's
not
right.
labeled on this chart.
Right. There'd be Gamma Ariatus,
Yeah.
the third brightest member.
Mhm.
And the nose of the
Mhm.
dolphin, that's a really nice double. That's really got a
Yes.
gold color too.
Yeah.
Oh, Menkar?
No. I mean the
Well, that
dolphin, not the whale.
Oh,
The dolphin.
That's
I
not
don't-
on this chart. I'm just
Okay, good. I'll stop looking.
blabbing.
Yeah.
Are we ready to move on?
Well, one
If
last
you want
question.
more blabbing, another really nice gold double is in Leo. Okay.
Algebra.
Yeah. Or Gamma Leonis.
The whale is called Cetus. There's
Mhm.
also, let's see, the star we're looking at is Omicron Ceti.
Mhm. Omicron Ceti.
Ceti.
Omicron Ceti. Mhm.
Even though Cetus is long E and Ceti
Yeah.
is shorty. Okay.
It's Latin for whale, Ron. So, cetaceans are, in that group.
Whales and dolphins.
Mhm.
Well, be darned.
Yeah.
But simians was, what is simians?
That's apes.
Apes.
Huh?
Apes.
That's
Ape.
right. Okay. Like my relatives. What are we going on to next? Dart? No, that's the moon
Oh.
again.
Looks like Mars.
Ooh, wow. Yeah, I see that at about midnight here, roughly.
Late Friday night, our two nearest heavenly bodies, Mars and,
Yeah, this is midnight
Oh.
on the 14th.
okay. Taurus the bull, huh?
Mm-hmm.
They're going to hang out between the horns of Taurus.
Mhm.
Mars is at magnitude minus 0.8.
Quite a separation between the moon and Uranus on this date.
Yeah.
Yeah.
Mars doesn't come up until way after midnight anyway.
Yeah,
I see it
Well,
about
this is midnight.
Yeah.
I see it around midnight.
Yeah, see, and there the eastern horizon is down here.
Mhm.
So it's just risen.
Depends where you live. Where I live near the ocean, the eastern horizon is nothing but fog.
Uh-huh. I ought to get an image of fog and put it in here. I can raise it and lower it as the weather requires.
That fog around the moon, does it ever get that bright?
Oh, no. No, I think it's just glow. I think Jerry's showing that the moon is still very bright and it glows.
Yeah.
Washes out.
This is the 14th, what it was, this is the 14th, and yesterday on the 9th, it was full.
Mhm.
So
Yeah.
this is 4 days after. So it's halfway to being last quarter.
Mhm.
So it's a gibbous phase. It's still pretty bright.
Yeah, you can see it's moving down towards the towards Gemini now too.
So when it's taco shaped, that's half moon, even though it's only a quarter of the moon's surface. Right now we're seeing full moon, but it's only half of the moon's surface. So everything is sort of half of the regular fraction, right?
Well, the half and the quarter are kind of referring to in it through its cycle.
Yeah.
Yeah, what we see.
So anyway, the
Trying to,
terminator on the moon is now in a gibbous phase.
Mhm.
And it gets to where just the terminator and on that date, the 14th, you can see these features near the terminator.
Mhm.
That Valles Alpes is really impressive.
Yes.
There's a little crack running right down the middle of it, not showing in this picture. And this is where you are on the moon, this square.
Mhm.
These two craters are very big, very distinctive. And of course, that's these two, Aristotle. There's a really good picture of Aristotle from one of the lunar orbiters or taken from one of the Apollo missions out the window, where it shows a very oblique view of Aristotle. It's just incredibly detailed. See all these little minor landslides inside the crater and all the layering. Spectacular picture, and it shows the curvature of the moon.
You're saying Friday night is the night to look at this? You can't see it now?
The terminator moves every night.
Mhm.
And so this is what it will look like on, I believe, the 14th or 15th.
Oh,
This is when it will look the most dramatic, Ron. So that's why.
Oh, the shadows, the angle of the sun.
Right.
Mhm.
And Valles Alpes, what made that scratch on the moon?
Debris from an impact.
Is it really?
Yeah.
Yeah, go ahead. That could be a ricochet, or it could be a big chunk that skidded along the surface from something else.
Huh.
It tends
The Alpine
to
Valley.
line up here, and there's a little white streak, but I doubt that something came out of there to create this damage.
Wow.
It could be just a ricochet.
It runs through a lunar mountain range called Montes Alpes.
The Alps.
The Alps.
And this is the Alps Valley, and these are the Alp Mountains.
Mhm.
Really? That's pronounced just like the European mountain range, Alps?
It's named after that. A lot of the mountain ranges on the moon are named after earthly mountain ranges.
Mhm.
Well, gee, I wonder who they named Aristoteles after.
Yeah.
it's a real good example of the difference in rays coming out from impacts between Tycho and Copernicus. Tycho is a high-speed impact, and you have the big splatter of rays that are almost straight. In Copernicus, you can tell it was a low-speed impact, and the ejecta kind of wobbled and rolled, and so the traces are not straight.
Well, Serenity Mare is near this, isn't it? It's not identified on this picture.
No.
It's not.
Well, it's kind of below and to the right down there.
Okay.
It's the head of the soccer player.
Okay, and it's a big wide
Soccer player. This is the soccer ball, right?
That's right.
And this is the head of the soccer player.
That's the head. Yeah.
Okay.
the Sea of Serenity. Do we happen to have an Apollo
Yeah.
landing craft sitting there? Did it land?
Yeah.
Land on Serenity
What
like
does
they
it
did?
say? Serenity Base here, the Eagle has landed.
No,
Well,
that's
that was Tranquility Base. Eagle has landed.
Tranquility Base, that's it.
Yeah.
Yeah. Didn't
Oh,
quite
yeah.
sound right.
but they had about 5 or 6 landings after 11.
6 total.
6 total, so 5 more. They had to have landed at Serenity. Are all the Maris named after such easygoing, lay down and get rest type?
I think
names?
the bigger ones were named after like emotions.
Oh,
The seas were not understood clearly when they were named after oceans, which they thought that's what they were looking at.
Mhm.
Well, you got them
They
all over
were.
the place.
They're oceans of lava.
Mare means ocean, like mare. It means
Sea means sea.
R-A, French for sea.
Yeah, you also see
The Latin for
Oceanus,
sea.
like Oceanus Procellarum.
Mhm.
Bruce, you were trying to say something. I talked over you.
The names are all over the place. Because you got the Sea of Rains, the Sea of Storms, the Sea of Clouds, the Sea of Damps, that's Humorum, the Sea of Serenity, Tranquility, Vapors, Crises,
Storms, Sea
Humility,
of Storms.
Nectar.
Yeah, the smaller ones had names that weren't emotions, but I think the big ones they kind of did emotions.
Yeah.
And so the reason they're vast and flat is they filled in with moon lava at one
Yeah.
time.
Mhm.
Yep.
Mhm.
It was liquid one time and then it froze.
Wow, and
So over here, what is this? This is Mare Crisium
No, Mare Crisium is a
Yeah.
soccer ball.
soccer ball. What's this? There's a bay right here.
I think that's Sinus Iridum,
Okay.
Bay
Now,
of
one of the-
Rainbows or something like that.
Mhm.
Okay. When I was starting out as a teenager, I was once a teenager, the 60s or late 50s, my telescope, we had a pamphlet and it showed that either this head at the end of the bay or this looks like the profile of a woman with her hair flowing behind her.
Right.
And a small telescope, it's very dramatic. You know, once you've read the brochure, then you can't get that image out of your head. So all of a sudden it starts looking like that. But much later, I look at that again, remembering this, but I can't remember exactly where it is. So now none of them look like a woman with her hair flowing. The power of suggestion.
Yes.
Anyway, this is a very dramatic part of the moon. There's a very old crater here that was obviously formed before all the lava came out and filled it up. And then these things here, and especially here, are post-lava. I don't know about this one. That's post-lava too, I guess. So I guess the seas formed very early in history of the moon. I think there were 2 or 3 major, what they call major bombardment eras. And one was before the seas, one was probably caused by the seas, and then we had one after.
Do any of you gentlemen remember the name of the spot where Kubrick, I guess with Arthur C. Clarke's writing, had the monolith unburied on the moon? Was that Clavius?
Yes, it was Clavius. Good memory. Clavius
Down
is,
in the south.
yeah, Clavius is down in this area.
Okay, Clavius. I'll just come
It's
back.
a very big crater, might be this, and it's got a very nice little arc of decreasing craterlets inside of it. It's very, it's its spotting feature. So anyway, okay, moving on to our attempt to make a crater of our own. This,
What is this we're looking at?
you are looking at a time-lapse image taken using the Hubble Space Telescope showing material spewing out from the asteroid following the collision.
Dart.
Dimorphos?
Yep.
Dimorphos is the
Dimorphos.
small moon,
Yeah,
and Didymos is the asteroid that it was orbiting.
yeah. So this is 22 minutes after impact. This is 5 hours after impact. And this is 8.2 hours after impact.
Okay. What was the name of the big mothership asteroid, the major one it's orbiting?
Didymos,
Didymos, that's right.
and it's not a major asteroid. It's not all that big.
Mm-mm.
It's major if this one's orbiting. How often
Yeah,
do you get orbiting asteroids? Wow.
No, that's fairly common.
Is it really?
Yeah.
I've grown up and got my age without ever hearing about asteroids having moons. It's like a moon having a moon, I guess.
Yeah.
They were referred to as double asteroids, like double stars,
Okay.
for a long time. The next view is taken by the Webb telescope, and it shows the thing in infrared. It's quite a bit more detailed, higher resolution, and much more impressive.
Wow.
But some of that is diffraction spikes.
1, 2, 3, 4, 5, 6. Good point. 1, 2, 3, 4. Yeah, certainly.
Yeah, although there's only
Well,
Certainly diffraction points are in there.
what did
6
NASA?
diffraction, 6
What?
diffraction spikes are suspicious.
So let's put it to size comparison. It would be like a Tesla car being rammed into La Playa Stadium.
No, it's more like maybe an oven or, you know, half a refrigerator being smashed into something. I think it was like 500 meters across, so 1,500 feet across.
And hopefully
That might be the parent body, actually.
Mhm.
so they didn't waste a lot of stuff on that probe by putting priceless instruments on it and stuff. It was just a big piece of metal shaped like a.
Almost everything that comes out of NASA is priceless.
Yeah.
But the camera, there was a camera on board and a transmission system, so it would send pictures back very rapidly, 1 per second. Very high data rate, so it's not a circuit to be sneezed at.
In an earlier impact, when they crashed into a comet, they put like 700 pounds of copper as the impactor because they knew there wasn't much copper usually seen in the spectra of comets, and they were interested in the makeup of the comet. But in this case, they just wanted to change the orbit. So they probably didn't bother putting extra weight, and all the kinetic energy was just in the speed at which they hit it.
14,000 miles an hour, I see. This one is a this shows an extent of 10,000 kilometers, the time this was taken. So this goes out 10,000 kilometers. See, this was taken with the SOAR telescope in Chile, which produced, this is a single long exposure of the collision aftermath. It shows the system leaving a long trail of material behind as the material is pushed away by radiation pressure from sunlight. This suggests a fair amount of material is likely to be escaping the gravitational field of the two asteroids. I know that NASA was planning on most of the material that would come off of the collision staying in orbit around the target body and not leaving the asteroid. So it's clear that a lot of it did. They expected most of the material would remain gravitationally bound. And it's not clear how well this image fits with the expectations. They will be on tomorrow, Tuesday, but I don't have the time. They'll give the first results from the after impact analysis of the Demodeus's orbit.
Now, did I misunderstand some early notices from NASA that there was a second part of this thing that separated and was not going to crash, but was going to take a picture of it crashing?
It took several pictures.
We showed those pictures last
week. In other words, the monitor detached from the one that crashed.
Yeah, it was called Lycia Cube, and it was a little shoebox size thing.
Okay, and so the pictures we do get, where do they come from? The one that crashed into it, or the one monitoring and watching it from afar? And it's now orbiting.
The pictures you got that were fairly close up of it, you know, where really you could see the boulders and stuff, were before impact, and they were from the impactor. And then there were some images sent from the Lycia Cube, and those are fairly close up, and they just show a big splash. They weren't high resolution. And now these pictures are from Earth-based telescopes.
Okay, but both of those parts of the probe, the one that crashed and the one that watched and took pictures, they had their own little antenna. Or does one send to the other like Huygens did to?
No. It was, and the Lycia Cube sent back the images really slowly because it has only a tiny, tiny antenna.
Well, Jerry's note says they speeded it up. Animation 500 times. Why would they want to do that? It's going fast enough anyway, isn't it?
Well, the pictures were only coming back at 1 per second.
Well,
or I'm sorry, it might have been even 1 per minute.
Well, that one that they showed in the news where it showed the rocky surface.
Yeah.
And then I guess I didn't get a picture as it was closing in. That was the last one was very close up. I wonder how close it was.
It was like 1,400 feet away, I think.
Really?
Yeah. And then they got the partial image where they crashed while they were transmitting the last image.
Oh, yeah.
And they'll know by tomorrow whether it altered its trajectory or.
They'll have some hints, yeah. I know there's a whole series of asteroid occultations being done with this system. Primarily, the shadows are going over Australia because they're trying to help out with figuring out the orbital changes.
Well, to be able to see a flash that bright from an Earth-based telescope makes me wonder, why don't we see that all the time with rocks, other asteroids hitting asteroids? They never collide, I guess.
They collide fairly often, but their relative impact speeds may not be quite as high.
Oh, that 14,000 miles.
Yeah.
Well, that's not the speed to get rid of Earth's gravity, is it? That's like 17,000 miles an hour to get into orbital speed around the Earth. Wouldn't you think they'd slowed it down or something when it got out into the, oh, this wasn't in the belt, was it? This was 7 million miles away.
Right.
And it's in its own little orbit in between us and Mars.
Yeah, and it's one that's potentially hazardous.
Oh,
Here's the Las Cumbres.
You see a share here
Yes,
of video animation?
yes.
Okay. This was taken with the Las Cumbres Observatory Global Telescope, the old name, 1 meter telescope at the South African Astronomical Organization or Observatory in South Africa. It's been speeded up 500 times, showing the effect of the DART mission. This long streak, it says, is an artifact of the camera. And I have cameras that do that too. So this shows it hitting and then the material coming off in an arc. So this was taken from Earth with a 1 meter telescope.
really? So you're saying something the size of a refrigerator, like Chuck was saying, can be seen from this far away?
No.
What are we looking at?
You're seeing the explosion. Okay, that's the explosion when it hit.
That's the asteroid and the gravel kicked off of it.
And what you're seeing there is is Didymos, the bigger asteroid. You're not even seeing Dimorphos, which is the one that got hit.
And from a distance, we can track that little dinky orbit around, one asteroid around another from this.
It's not because you can see the asteroid going around. It's because the asteroid occults, it goes behind, and so the brightness changes suddenly. Excuse me, I gotta close the door to block the dog barking.
It's a dog.
That's a
Yeah,
dog.
so they look at how the brightness changes as these two things orbit, and they can tease out the orbital period.
Yeah, they time the time between the blinking when it goes out and when it comes on. The time will change if the orbit changed. So if you can tell if this thing is dimmer now and brighter there, the difference is there. But I'm joking, you can't tell that.
Just out of curiosity, from a standpoint of another NASA mission we had talked about last Monday, a week ago, we had the young man who's a NASA ambassador tell us about the Lucy mission. That's another one that's happening soon. It's going by the Earth, this weekend?
On the
It's getting a
16th.
gravitational assist, yes.
By both the Earth and the Moon. It's going to swing by on its way to Jupiter's asteroid belts, or whatever they call the Trojans, right?
Yeah.
Gentlemen, we have 5 minutes if you want to talk about a giant star, a red giant, supergiant that went supernova 120 million light years away. Good Lord, that means it happened that long ago.
Yeah.
But this is the first time we've seen, that's what it said in your notes, the first time we have never witnessed a supernova explosion before.
We've never watched the process
From beginning to end.
with a good time sequence. I mean, we've seen stars that have subsequently blown up, but it was usually a long time before they blew up, they weren't continuously monitored. And this is a case where they watch this star closely with a cadence that gives you some idea what's going on.
Right.
And so they were seeing these odd eruptions happen before it blew up.
So what they're seeing is spectral changes, not spectral changes, brightness changes, and they're interpreting those. This is not a photograph of the star. This is an artist rendering of what is believed to be happening on the star. There's a lot of violence, a lot of turbulence, a lot of energy boiling to the surface before it finally erupted. The picture that I've always had of these things is that the whole surface uniformly and spherically, symmetrically blows up. But apparently it doesn't do that. It wobbles around and parts go up and then finally the whole thing goes. It has to be a collapse part where the core collapse eventually gets triggered.
Gives us a neutron star.
This is not a neutron star. This is a super red giant, a super giant, big star, Betelgeuse type thing.
But the end result, Ron, may be either a neutron star or a black hole.
Yeah.
Right. But 120 million light years away, the galaxy it's in would be a little dinky blob, wouldn't it? How in the world can they zero in on one of its stars?
That's not all that far away.
120 million?
Yeah, that's not that far away.
Okay.
In the big scheme of things. I mean, with Hubble, I think they can measure Cepheid variables up to 300 million light years. I mean, that's tremendous.
How
Yeah, you
far?
have to see the light from an individual point to do that, and you can. Yeah. I've seen very dramatic pictures of the Andromeda Nebula completely resolved into stars. You can see individual stars in it. So it's easy to do some of these big, and that's with Hubble, I think. So there's bigger telescopes that can do that farther out. And
it was the 100-inch that let Hubble resolve an individual Cepheid in the Andromeda Galaxy.
Right.
So.
Wow. Okay, well, they're the biggest stars in the universe, and just for the record books, it's SN 2020 TLF. You know what TLF means?
That's like for comets. The SN means supernova.
Right.
And then the TLF is going to be what portion of the year it occurred in, and then a sequence that they saw it.
In 2020, 2 years ago.
Yeah.
And do they have a name for the galaxy it's in?
Oh, sure. It's going to be.
They do, but I didn't record it.
It's probably some NGC, huh, Chuck?
Pardon me?
It might be some NGC.
Yeah, probably is, or an IC.
At 120 million, yeah.
They spotted the star with its odd outbursts and started tracking it for 130 days using two telescopes. One in Hawaii, the University of Hawaii, both in Hawaii, the Institute for Astronomy Pan-STARRS telescope, and the W.M. Keck Observatory on Mauna Kea. At the conclusion of that time, the star finally exploded. Wow. So they're working with magnetohydrodynamic equations of plasma to account for brightening, the sporadic sparkling and brightnesses. These are the results they come up with, a detailed map. I'd like to see a time result map of that. I bet that's very dramatic.
Yeah.
But it's derived, not observed.
So is this star just like our Betelgeuse, which is on the verge of doing the same thing?
Yep.
Yeah, it's probably very similar.
Yeah.
Except that Betelgeuse is relatively close to us, right?
Yeah.
And when it goes, it will have happened 600 years ago, I suppose. That's how far.
Yeah, that's about right. Mm-hmm.
But it still could hurt us?
No.
I don't think so.
No, the ones you got to worry about is if they have, like you can see this image here of this explosion, it's asymmetric. And you can have these gamma ray bursters that we think are supernova, core collapse supernovas, where the axis on which they spew this stuff out happens to be pointed right at us. That would be a problem really far away. But Betelgeuse's rotational axis isn't pointed towards us. It usually appears to happen on the rotational axis. And so we don't have to worry about that.
So asymmetrical means it's not totally a spherical shape.
That's right.
Mm-hmm.
So this, when it exploded, the researchers saw evidence of a dense cloud of gas encircling the star that had been thrown off for quite some time beforehand, just like Betelgeuse is doing now. It's throwing off lumps of gas and debris that sometimes occult the star. When this one exploded, they could see that debris around it, they feel. So,
More reason to watch Betelgeuse.
right. So their conclusion is that red supergiants suffer considerable change in their interior structure, culminating in chaotic eruptions of gas in their final months before crashing. So Betelgeuse may happen after midnight, to quote Tom.
Yeah.
Well, now, are there different levels of this? These red supergiants are the biggest. Are there red giants? I know there's red dwarfs. Is there a whole level?
Yeah, there's red giants, and there are also hypergiants, they call them, which is what they didn't mention here. But if you get these really, really big supergiants, they start calling some of them hypergiants.
Yeah.
And if our sun was one of these, we'd be in the middle of it, wouldn't it?
Yeah, reach out to Jupiter or more.
Yeah. Yeah.
Yeah, we wouldn't be.
That's
We'd be
crazy.
vapor.
Yeah. Well, look, this has been a fascinating hour, gentlemen. We're down to the wire and got lots of things to look forward to. Maybe a pizza delivered once or twice before the years. Thank you very much. The four of you. We missed Tom Totten, but Bruce, anything going on at the Oregon Society you want to tell us about?
We're having an open console a week from this coming Saturday.
Oh, all right.
From 9 until 11. Enter by the Solar Street side door. It's free to the public.
Okay, gotcha. We'll be there. And Chuck, 2 weeks, right? We go meet at the camp out
Yes.
and get fed. And Jerry, thank you very much. Good luck in your campaign in December to keep your job, and I'll look forward to being the heart.
For the members' night, I'm gonna show slides of the observatory I built in the backyard.
Oh, good.
Fantastic. And Tom Whittemore, thank you. Thank you, Bruce.
Thank
We'll
you.
see you next week for number 86 of the Santa Barbara Astronomical Unit.